Okay, so let's move to the next talk. My name is Álvaro Alonso. I'm here with Cyril Dangerville. We are part of the security chapter in FIWARE. Today with us are also Pascal Bison and also our colleagues Federico Fernandez and Joaquín Salvachua. We are all of us part of this FIWARE Security Chapter. So during these days, if you need help or you want to discuss anything about this, about security in FIWARE, you can of course talk with any of us. Okay. So let's start with this talk. This time, Cyril and me will present this part of this track, and what we want to explain you is how to manage identity in FIWARE. Okay, how to manage authorization and authentication in FIWARE ecosystem, and to understand what exactly identity means in FIWARE, we also like to start with an example that probably all of you already knows. Okay, and I would like to ask you how many of you has a Gmail account here in the room. Okay, yes, probably a lot of of you. Okay, and how many of you has a I don't know, Hangouts account? Not all of you. And a Google Drive account? Yeah, okay, probably what you have to know is that if you have a Gmail account, that means that you have a Google account, and that means that you already, you also have a Hangouts account, a Google Drive account, and an account for using every service that Google is providing you, okay? So you have a single account, Google account, and even if you if you don't explicitly know that you also have an account of all these other services, you actually have it, okay? So you have a single account, and with that single account, you are able to access every service in the Google ecosystem, okay? And this is more or less what we want to provide with FIWARE, okay? We want to provide, yes, it seems all of us have the same problem here. Okay. This is the thing we want to offer also with FIWARE, okay, with FIWARE account. We want to provide a single entry point in identity in order to allow you to access every service in FIWARE, okay? But not only every service already available in FIWARE, but also every service you want to deploy. You want to design, you want to develop, and you want to deploy. Okay, so we provide a single identity entry to use every services in FIWARE Lab, but also every generic enablers we provide in FIWARE, but also we want to offer you the possibility of adding this identity service to your own service. So if you want to design a service, an application, and you want to allow FIWARE users to securely access your service, you can also do it using the things we provide in security chapter, and we are going to explain you today. Okay, so this is the aim of this talk: explain you how you can use these FIWARE services, but also how you can add to your services the possibility of using this service, okay, this identity in FIWARE. This is possible. This mechanism is possible thanks to a standard called OAuth2. I don't know if you already know what is this protocol, but this is a standard that is used by all these services you can see in this slide, and of course, it's used also by other services, a lot of services that we can consume today in the internet, okay? Probably you have experimented, right, when you enter I don't know, a service like, for instance, SlideShare or so on, they give you the possibility of logging using your Facebook account or your Twitter account, right? So when you click in this kind of buttons, you are using your Facebook or your Twitter credentials to authenticate in an external service, in this case, in SlideShare, okay? So this is possible thanks to this standard, to OAuth 2.0, and this is the standard we also use in FIWARE to provide this possibility, okay? So from today, you can also use a button like this, or you probably will see this button in the future, okay, in several services. As I said before, this is possible thanks to OAuth 2 protocol, OAuth 2 standard. It's a mechanism that allows to provide applications the possibility of access restricted resources using the credentials of the user. Basically, the things you are doing when you use this login with Facebook button. Okay. To understand this protocol, it's important to understand the different roles, the different type of users that, or the different type of entities that take part in these mechanisms, okay? We have a resource owner that is the entity that actually owns the resource, okay? In this example, following with this Facebook example, the resource owner is the user that owns the data, okay? The data that the external application is trying to access. We have the resource server, that is the server in which that data is stored. In this case, it's Facebook, okay? In the Facebook servers, that private data about the user is stored in the Facebook database. So this is the resource server, the server where those data is physically stored, okay? Then we have a client that is the entity that is trying to access those resources, those private resources, on behalf of the resource owner, okay? So, for instance, when you are using a SlideShare, when you are logging in a SlideShare using your Facebook credentials, the client is the SlideShare server, okay? The entity that is accessing your data on behalf of you. And finally, we have the authorization server that, frequently is the same one that the resource server, and is the actor that is providing the access token. We will see now what are these tokens that are the keys that you can use to securely access these resources. Okay. OAuth 2 provides the specification, provides different configurations, different possibilities that you can use when configuring it. Okay. The first one is they call grants. Okay, these different configurations are called grants, and we have 4 types of grants. The first one is the authorization code grant, in which here in this picture we can see the client, that is the server that is trying to access your resources on behalf of you. We have here the resource owner. In this case, is FIWARE. Okay, let's start talking about FIWARE. Let's forget Facebook. So it's the server that actually has your data, your resources, and then you have the client, okay, that usually using a web browser is trying to access these resources using this client server. So the flow between all these actors is the one you can see in this picture. When you enter in the web browser and click on this button, login with FIWARE account, the web browser is trying to access your resources through this web server, okay? And this server said, okay, this is a resource that is protected and that is owned by a FIWARE server, okay? So I'm going to redirect you to the FIWARE server. So your web page now redirects you to the FIWARE account server, and then you can see in the navigation bar that now you are not in this server, okay? Now you are here, and now FIWARE is asking you to enter your account credentials, okay? Your login and your password. So this is important. You are not using your credentials here, so this server is not aware of your username and your password. You are always introducing your credentials here in this server. If the authentication succeeds, this server will redirect you again to this server with a response code that is a string that this server has to use to finally validate the flow with the server. And of course, this last request is sent from server to server, okay? So it is always secure. To perform this final request, this server needs to send the response code that it has received from FIWARE, but also the credentials of this service. So previously, you have to register this external service as an authorized application here in FIWARE Lab, okay? We will see later how to register this external application here in FIWARE, okay? And as you can see, the result of all these requests and responses is that this server has an access token. It's a token that represents the user that has logged in, and that can be used to access the protected resources of the user, okay? So it's easy, it's not a hard mechanism, but of course, you have to implement it in your application. So imagine you are developing this server, you have to implement this flow in your code, okay, to perform this mechanism. This is the more frequently used grant, okay. So I have included here the details of the request you have to perform. The first one is the response to the request you have to send to the account server in order to redirect the user to it. Then you obtain the code in your server. This is the code you have to send with your service credential to the FIWARE account. So here you include in the next request the code you have received, and also here in the authorization header of the request, of the HTTP request, you include your service credentials, okay? The result of this flow is that you finally have, in case of the FIWARE account, a JSON response with the access token and yes, the expiration time and another token to refresh it and so on, okay? So this is the set of requests you have to interchange with FIWARE Lab server in order to perform these mechanisms. But don't worry, because okay, yeah, I will say show you the link later. But don't worry about this mechanism, because there are many libraries available for different languages. So, for instance, if you are developing your server in Node.js or in Python and so on, you probably will have libraries that allows you to perform these mechanisms without having to know the low-level details. Okay. So, as I said before, this is the most common mechanism, the authorization code grant. But there are 3 more grants available in OAuth 2. This is the implicit grant mechanisms, in which you can see that the main difference is that here in the first request you send to the server, you already include the credentials of the user. Okay, so this user using these mechanisms, has to introduce their login and password here in your server. Okay, so in this case, your web server knows the credentials of the user, so it's not so much secure that the previous one. Okay, but this is also a mechanism that that is available in OAuth 2. The next one is the resource owner password credentials grant, in which the communication between the web browser and the FIWARE lab and the resource owner server is not needed, okay? And you send here directly the service credentials and the user username and password credentials, okay? The result, as you can see, is always the access token that that this server creates for this external application, and that represents the user. And finally, we have mechanisms that is there is a typo here. This is resource owner password credentials, and this is client credentials grant. Okay, this is a typo. And in this case, all the mechanisms is based on the credentials of the service. Okay, so here we don't use the credentials of the final user, let's say. We directly use the credentials of this service in order to perform the flow. But again, we have an access token, but in this case, the access token does not represent the final user. In this case, the access token represents the application, okay? But this is a flow that in some use cases can make sense also, okay? So, as I said before, you don't have to know all the details of these mechanisms. You will find in this web page, in the web page of the OAuth 2 protocol, details about several libraries for many languages that allows you to easily configure all this stuff in your server, in your application server. Okay, so don't worry about the details, but always it's better to know how the mechanisms work, because then you will be able to, for instance, to choose which of these available grants is better for your use case. Okay. We also in FIWARE provide a Node.js server application in which we of course use a Node.js library, one of these ones, and we provide a very simple example in which you can, using your FIWARE Lab account credentials, you can log in this simple application and see how the OAuth 2 flow is working using the first grant, okay, that I have just explained. So you can download this code. We include also the instructions to install and configure it, and you can start testing it, okay? We have not right now the needed stuff to perform a demo, but of course, if you want to see a live demo of this thing, you can search up later, and we can go to the security chapter room and perform you the demos or whatever. Okay. We also provide in the FIWARE Academy platform several courses, several lessons explaining these kind of things with live demos and with extended documentation and so on. This is also available in FIWARE Academy. Okay, so this is the place in the FIWARE account portal where you have to search for these credentials for your application. So when you register an application in the FIWARE account portal, you will obtain a client ID and a client secret that are the credentials you have to use inside your application to be able to perform all these requests to FIWARE account server, okay? In this kind of libraries I recommended you just before, you probably will have a configuration file in which you can introduce directly these credentials. Also the URL of the authorization server, and probably with those basic configuration parameters, you will be able to perform all this stuff. Okay. Again, if you want to know details about how to register applications and so on, you can check the documentation we provide, the courses we provide in the academic course, and of course, during these days, ask us anything you want to discuss, okay? Okay, so finally, when you have performed all this flow using one of these 4 available grants, you will have an access token in your web application, in your server, and you will be able to request to FIWARE account server the protected information about the user that has logged in the platform. This is the request you have to perform, and including here the OAuth2 token, you will retrieve the protected information about the user. So finally, an access token represents the user instead of their credentials, okay? The first time a user log in using this mechanism, he's asked by the FIWARE account to give permission to access those resources, okay? Probably you also have seen before, when you log in with your Facebook account, you get a list of things that the external application wants to access from your account, right? They say, yeah, Slicer wants to access your public information, your friends in Facebook, your public profile, and so on, okay? You have to authorize this application to access those things. So here in FIWARE account is the same thing, okay? But this is only done the first time you access the application. So, summarizing, you have an access token, and with this access token, you are able to access this protected information about the user. But this is not the only thing you can do with this access token, because, as I said before, in FIWARE, we use this identity service, this FIWARE account service, to allow the secure access to all the services we provide in FIWARE, okay? So these services also include the generic enabler, the different generic enablers from different chapters we are offering in FIWARE, okay? So using this access token, you can also send requests from your server, from your service application. You can perform requests to any of the available generic enablers we have available in the FIWARE Lab environment. Okay, so probably these generic enablers are compatible with FIWARE identity, and just including in your HTTP request, in your REST request, a header with the access token, you can be able to perform this request to the generic enablers, the available generic enablers. What is happening inside these generic enablers is that the generic enablers receive a request and checks the header of the request in order to find if this is an authenticated request. If so, he gets the token from this header and try to validate it with the FIWARE account server, okay? Try to say, okay, I have received a request from a user with this access token in the header. This is a valid access token. This user is authenticated or is authorized to perform the action he's trying to perform. And then FIWARE account say, okay or not okay. In this case, FIWARE account say, okay, yes, this user is authorized to perform this action. And then the generic enabler performs the action and responds with the requested information to the web application. Okay? So what is happening inside this generic enabler is that the developers of this generic enabler has introduced a component that we also provide from Security Chapter, and that is called PPProxy, okay? Vilma generic enabler. This is a component that basically do the thing I have just explained. Gets a request, extracts or try to extract this access token from the headers, and perform a check with FIWARE account server in order to try to validate this request, okay? So what these generic enablers are doing inside is to simply install this FIWARE PPProxy. So in the same way, they are using the PPProxy to add security to the resources they are offering, you can do the same with your custom backend application. So when you design and deploy a backend application based on REST and on HTTP, you can include a PPProxy on top on your REST API in order to secure the resources you want to secure. This way, you can decide to which users or to which groups of users you want to permit the access and to which groups of users you want to deny the access to your services. Okay? Of course, these PEP proxies are going to perform some validation requests to FIWARE account servers. So these servers has to have the needed permissions to send this validation request. Okay, we are not allowing this request to every service in the internet. And in order to do so, you have to register the PEP proxy of your application, the PEP proxy associated to your application, also in FIWARE Lab account. And it is done here. In the same way, here in the information about your application, you retrieve your OAuth2 credential to configure the flow. You can also register a PEP proxy that will be able to validate these tokens with the FIWARE account portal. Okay, so here you register a PEP proxy and you get a username and a password that you have to configure in the PEP proxy configuration file. This is also very simple. We provide an administrator guide that shows you how to configure these kind of things. And again, you can ask us or whatever if you have doubts about that, okay? So these mechanisms of securing a backend application using FIWARE proxy can be done in several levels of security, okay? And some of them implies another important generic enabler we offer in the security chapter. So my colleague Cyril is now going to explain you how these mechanisms work, including these three generic enablers of the security chapter. Okay, so Cyril.
Thank you, Álvaro. So I will go into further details on what Álvaro just explained, but emphasizing the authorization part and the use of the PDP, the policy decision point generic enabler. So the FIWARE access control architecture, or the IAM architecture, identity and access management architecture, is quite flexible. So you have different ways of using it depending on your needs. So the most basic level is authentication. So in this context, you use the FIWARE access control architecture only for authenticating your end users, for identifying and authenticating your end users, and using, of course, the FIWARE account server or another instance of the FIWARE identity management generic enabler. Then you have level 2, which is basic authorization. So in level 2, you include level 1, so you need authentication first, and then you can do the authorization part. So authorization is a little bit more than authentication. You check that the user has the necessary permissions to do a specific action on the resource, on the target resource. So the action is typically the HTTP method, and the resource is the URL path and the web site or the REST service typically. And then the last level, the more advanced level, is level 3, advanced authorization. So the main difference with basic authorization is that in basic authorization, it's either identity-based access control, like you're just checking that the user has a specific ID to be able to do this permission, or role-based access control, so you're just checking the role of the user. And in advanced authorization, you're using a more generic kind of access control, which is attribute-based access control. So attribute-based access control is like a generalization of airbag. So instead of using only roles, user roles as the basis of your permission definition, you can use any kind of attribute, not only role, but organization, user organization. You can use attributes of the action, like the action ID or the action parameter. You can use attributes of the resource, like the resource classification, the sub-resource of the main resource ID, and so on. You can also use environment attributes like the current time or the location of whatever, or also the risk level, which can be used as an environment attribute, and so on. So getting into more details. So when you use just authentication, you use the PPProxy that Álvaro presented already. And the PPProxy will check the incoming access, the access token in the incoming request against the IDM, so the FIWARE account. The FIWARE account gives all the user information on all the information in the context of the token, of the access token. Like, is it valid? The expiration date of the token, and also user roles, user organizations, and user ID, of course. And other nice things like the user display name. So this can be useful if you want to customize the interface, the user interface, using the display name in your in the user GUI to display the name of the user. And this is, so in this kind of context, the authorization is not done by the PPProxy. So in the PPProxy, you can disable the authorization part just to do the authentication. This means that you have to do the authorization on your own, in your backend application, in your own way. So usually you may have your own authorization logic embedded in your application already. So you don't need the PPProxy to do the authorization. But you have to know that you could do it as well with the PPProxy, especially if you have a REST service, because it has a nicely defined API, which is easy to protect with a reverse proxy. So the PPProxy is a kind of a reverse proxy. So if we want to do basic authorization, this means that in the IDM, you have defined some permissions. So you define the roles in the IDM portal. For each role, you define permissions that you assign to the roles. And then you assign the roles to your users. So each user should have been granted a specific role to be able to access your application. And this results in airbag policies pushed to the authorization PDP generic enabler. So this is the new enabler that we haven't talked about so far. And the IDM is actually, when you define the roles in the IDM, it is pushing the policies to the authorization PDP. So basic airbag policies. It's using a language called XACML, which is an Oasis standard for defining policies. And then on the PPProxy part, so when a user tries to access the backend application, the PPProxy will, of course, do the authentication like before. And then for the authorization, we'll send a XACML request to the authorization PDP. So a XACML request contains all the kinds of authorization attributes that you need to enforce the permissions. So in this case, it's the user role, the HTTP method that is requested, the path, the URL path, and the REST service. So this is the resource ID, basically. And then the authorization PDP replies with permit or deny. So if, according to the policies that you have defined, it is authorized to do this action, it replies permit, otherwise it replies deny. And then you get the access is forwarded by the PPProxy to the backend application if it's permit. If it's deny, it's rejected with a specific HTTP code. So this is an example of editing the permissions for each role. So maybe you have used it already. You just define the name of the permission, the description, the verb, like the HTTP method, get, put, post, delete, and then the URL path. So the resource is the URL path. So I think you don't put the slash at the beginning. You just put then the next part of the URL, and that's it. You save, and the policies is pushed to the authorization PDP. And then the advanced authorization. So if I go back here, you see at the bottom that you have advanced XACML rule. So when you use that, you can do advanced authorization. So you can specify, define more complex policies, which is attribute-based access control policies, that will be pushed to the authorization PDP as usual. So the rest of the flows are the same. The PPProxy will do the authentication, then the authorization with the XACML request. But in the policies enforced in the authorization PDP, you will do more complex things. So the policies will be more complex, using attributes with more complex functions and things like that. So you can do some more complex attribute-based access control policy there. So the flows are the same. It's only the evaluation of the policies in the authorization PDP generic library, which is a little bit more complex. And see here, you can see an example of XACML rule. So this is using the XACML syntax. So it's a little bit more complex than the rest of the editor. And you see that you can use functions, you can use a combination of Boolean expressions and so on. And so you can do more complex stuff. And back to you, Álvaro.
Yes. Thank you. So the last thing we want to explain you in this talk is a feature that we have recently added to this security ecosystem, and that is the possibility of integrate identity with IoT part of FIWARE. Okay, probably you have seen how IoT sensors work in FIWARE in the previous talk. Also, how context management is used in FIWARE, and the result, summarizing, is that we have sensors that are context producers or context consumers, and that will send requests to the context management generic enabler, the Orion Context Broker generic enabler, in order to publish and subscribe to information in this environment. Of course, if you want to add security to this stuff, we have to authenticate sensors. And of course, if we are talking about providing a single authentication point in FIWARE, authentication and authorization point in FIWARE, we have to include this sensor authentication there, okay? So what we have included is the possibility of allow sensors to create tokens to authenticate in FIWARE by themselves. So the final architecture is the one you can see in this slide, in which we have a context producer or consumer that is creating tokens by themselves, by itself in this FIWARE account portal. So the request that this sensor sends to the FIWARE context management generic enabler are authenticated in the same way the requests that a user sends to these backend services are also authenticated. Okay, so Context Broker inside Context Broker has also a PPProxy inside that is getting the request sent by this context producer and consumers and validate them through the with the FIWARE account server. Okay, so using this configuration, we allow sensors to perform this update and query actions in a secure way, also in following the standards of security in FIWARE. Okay. Of course, again, to be able to create these tokens in FIWARE account portal, these sensors has to be registered in FIWARE account, and we provide a new tool in the FIWARE account portal to allow this sensor registration. So in the same way, you can register a PPProxy here in the application part of this portal. You can create as many IoT sensors as you want. So when you register a new sensor, you obtain a IoT sensor username and IoT sensor password. Okay, and using these credentials, you are able to create tokens for the sensors. Of course, you can reset the password. You can also delete the password. You can also use these credentials that are associated to my account, but I will remove them after the talk. So, okay, so basically we have all these things, all this stuff we have just presented is possible thanks to the 3 key generic enablers we have in the security chapter. That are the identity management key rock generic enabler, the authorization PDP that is called Force, the main implementation is called Force, and finally the PPProxy Vilma generic enabler. Okay, identity management is in charge of all this stuff, managing users, managing applications, managing organization. Okay, tomorrow we have hands-on explaining how you can install and configure your own instance of this generic enabler. It's very interesting. I recommend you to attend this talk. The authorization PDP is in charge of managing authorization in FIWARE, the PDP and the PAP part of the authorization. And finally, we have this proxy that is in charge of managing PEP, police enforcement point of the authorization part. Okay. We are going to give you some pointers for documentation, but always these days are a good moment to directly discuss with us anything you want to discuss. But basically, you have here information about the main or the more important parts of these generic enablers. Okay, in case of the key-rock generic enabler, you have to know also that inside this generic enabler, we have modifications of Horizon and Keystone projects of OpenStack. So this generic enabler is totally based on OpenStack. We are aligned with the community, and we are trying to contribute to the OpenStack community in every moment. So this is also a good point of this enabler. And we implement APIs like OAuth 2, Keystone, and Scheme 2.0 in this generic enabler. You can find here the source code and also, of course, the documentation. I have also included here the link to this example that I commented you just before in order to test this OAuth 2 part. And yeah, my recommendation is that you go to the catalog, because this is the main entry point in order to go to the installation guides, the user guides. Also, there you will find the image that we offer in the cloud portal in order to basically quickly deploy this component. Also pointers to Docker, Chef, and other mechanisms we have to easily deploy this enabler. And the same thing for PPProxy generic enabler. Okay, the source code, also the entry point for the documentation, and the global instance that in this case is not here, but yes, exists. So Cyril is now going to explain you the Force.
So you've seen the IDM, you see the PEP, so now the PDP. So PDP is policy decision point, as Álvaro said. So it's, well, actually to be accurate, it combines PDP and PAP, so policy administration point, because at some point, before you can enforce policies, you first need to manage the policies. So to be able to push the policies, to change the policy and so on. In FIWARE, we choose to implement ABAC, attribute-based access control attribute-based access control framework, because we feel that it is the future of access control, and it's already becoming a very important trend in access control. And as you can see at the top, Gartner said in 2013 that by 2020, the majority of enterprises will use ABAC as the dominant mechanism to protect critical assets, up from less than 5% today. So today is 2013. So now, obviously, we're a little bit more than that. So the FIWARE authorization PDP today is the only more or less standard specification for both PDP and PAP. In form of a REST API. So if you go to the OASIS consortium, you will see a REST profile for XACML, but it's only the PDP part, and it's very basic. You don't have the multi-tenancy aspect for a cloud application, for instance. And here in FIWARE, you have the multi-tenant, so you can have multiple domains, and each domain can have its own PDP and its own PAP. So you have some kind of logical isolation between the various PDP, PAP, and policies associated with them. And it's also the only open source 100% compliant with XACML 3.0 with a REST API like this. So you have other implementation of XACML, but not with a PAP and PDP REST API. And it's implemented the XACML 3.0 standard, and also extensions of XACML that we call the XACML profiles. So you have the REST profile, obviously, the RBAC profile. So you can still do RBAC with ABAC. So ABAC is more like a superset of RBAC. And you can also do multiple decision. So multiple decision is when you want to request, so to do multiple individual decision requests in the same XACML request, so you can get multiple decisions in the same payload, so in the same XACML response. So this is a very useful way to multiplex multiple access decision requests in the same payload. And also for performance reasons, so for performance optimizations, we implement another standard called fast infoset, which is an ISO standard. So this basically improves the XML processing and the XML size, the size of the XML payload. And it's also extensible. You can plug in your own attribute providers. So attribute providers is when you want the PDP to get an extra attribute from an external source of attributes, an external attribute provider, like SQL database, an LDAP directory, or another REST service, like the context broker, for instance, and use that extra attribute to evaluate the policies. You can also use extra functions and so on. And the last point is that you can do PDP clustering. So again, for performance reason, you can have multiple PDP instances in the same cluster. And this way you can handle extra load for enforcing your policies. And that's it for the presentation of the PDP. So you can, of course, go to the catalog where you have all the information on the PDP. You have a FIWARE lab image if you want to instantiate PDP instance quickly. which is called Authforce 5.4.1. So this is the last version of the PDB. You can also look at the API in the APRE format, so I would say a textual format. You can also get the source code of the Authforce generic neighbor on GitHub. You also have the API specification in technical language, so which is called WADL, the Web Application Description Language. So WADL is very useful if you want to generate the client code automatically. So you have various tools, like in Java, for instance, you have tools to generate the client, the Java code from the WADL. It's like WSDL, but for REST services, and you can generate the code automatically. And then we distribute Authforce in various formats. So we distribute it in a Debian package or Ubuntu package, and also for other Linux distributions, you can get the tarball, the tar.gzil, and we also provide the Docker container on the Docker Hub. So you have the link there, and we also provide a global instance. So it's just a public URL that you can use to test rapidly your the Authforce API. And finally, we provide the documentation on Read the Docs, and you can get the link from the catalog, of course. And that's it for the G's. Not working. Yeah. So thank you for your attention. And there will be a demo or presentation about the IDM tomorrow in the morning, I think, or yes. Yeah, tomorrow morning. So if you want more details about the IDM, and if you want to have more demos, we can show them in the room that is dedicated to a security chapter if needed. So if you have any questions now, go ahead. Oh, we have one question there.
I'm not sure if I understand well. In your presentation, you talked about to us about the FIWARE account and the FIWARE lab, correct? So when I want to use another system as a production system, the Docker, that I have implemented my series there, can I use the same mechanism as well? Can I do something different, or should I do something different?
Yes. You can use both options, let's say, both configurations. If you want that FIWARE Lab users are able to access directly your services, you can connect your environment directly to FIWARE Lab instance of Keyrock and Nausicaa Force. And then any FIWARE user that wants to authenticate can use their account, okay? But probably another possible scenario is that you want to have your own set of users in your environment, and then you can deploy your own instance of these components of FIWARE, of Keyrock, Nausicaa Force, and so on, and then users will have to register on your service instead of the FIWARE Lab. Yes, exactly. If you want to know how to install these components, I recommend you to attend our demonstration tomorrow. Okay. So yes. Yeah, the only one that has the GUI is the Keyrock generic enabler. The other ones are backend components, so they don't have GUI.
Yes, for the PDP, you can use the IDM portal to edit the policies for basic use cases, like role-based policies. If you want more advanced XACML policies, if you want to use the full power of XACML, then you have to use your own REST client with XML. So, yeah. Yeah, another question?
Yes. Keyrock is based on both Keystone and Horizon. Okay, the backend part is based on Keystone, and the front-end part is based on Horizon. But what we have done is to introduce several extensions that we need to perform all the things we have just showed you. For instance, extensions to be compatible with Steam, to be compatible with Authentication Force, to be compatible with sensor registration, with OAuth2. There are several things that we need here in FIWARE, in security, and are not included by default in Keystone. Okay. Again, tomorrow we will enter in details of all the things, all the extensions we have included from a vanilla Keystone implementation. Okay. Okay. So. If there are no more questions, we can go lunch. And thank you very much for your attention.
Thank you.
See you later.